Spent some time going through volumes of revolution when we were rotating about a horizontal axis. Now we're going to rotate about a vertical axis. So we're going to start by rotating about the y-axis, and then we'll venture off like we did yesterday. Okay? Well, if we're going to still create discs and washers, then we need to have horizontal rectangles to rotate around those vertical rotations. Okay? Now, if we have horizontal rectangles, that means their thickness will be dy. Okay? So as you can imagine, we're going to go through the same process, except now we have y instead of x's. All right? So if you think about, and don't write anything down yet, if you think about a region that we rotate around we'll just start with the y-axis, okay? If we have these rectangles with thickness dy, then we're still going to create these discs and washers where the volume of a disc, thank you, the volume of a disc is pi r squared h, okay? Well, the height of this disc is dy, okay? And the radius we're going to measure with our different functions. So once again, we have pi r squared minus r squared h that we are going to throw into an integral so that we can add up all of those discs and or washers depending on the curve. Okay? But since we're doing this with horizontal rectangles, our thickness is dy, which means our equations need to be written in terms of y. So now that we have a second method, okay, well, and it's not really a second method, it's the same thing, but we're going about a different axis of rotation. But now that we have that, it is going to be important that you draw in those rectangles so that you can imagine what's happening, okay? Every time you do a problem, I want you to draw in that rectangle and imagine, is it making discs or washers? Because if it's not making discs or washers, then you don't have your rectangle set up correctly. Also, after our quiz, we have a quiz Wednesday. On Thursday, I'll teach you what's called the shell method. And so there's going to be two different methods for finding volume. So we really need to be in the routine of drawing those rectangles so we can keep organized. Okay. So go ahead and write this down. Write down the equations at least. So this would be x equals 2. You agree? Y equals 0 is just the x-axis. And then we have our parabola. But probably only that part of the parabola since we are bounded by the x-axis and x equals 2. Now we are going to rotate about the y-axis. And in order to create discs or washers, in this case washers, we need these rectangles with thickness dy. Imagine these rotating around. Are you imagining those rectangles creating washers? Okay. So since our thickness is dy, then we are going to have to use y values. Okay? Our limits of integration need to be in terms of y. Our function needs to be written in terms of y, or I guess our equation needs to be written in terms of y. We'll integrate with respect to y. Okay? So, let's figure out our limits of integration first. Where do we start? 0. Okay, now we need to figure out what this coordinate is, but we care about the y value. Well, we know the x coordinate is 2 because this is x is 2. So when x is 2, what is y? So we're going to go from 0 to 8. Those are the y values of our region. Okay. All right, so our outer radius, which one is furthest away, the parabola or the line? The line is furthest away, and it is the line x equals 2. So from 2 to 0, that is our outer radius. Okay. Our inner radius would be our parabola to the y-axis. Well, can we put 2x squared? That's our parabola, isn't it? We need to be in terms of y. Okay, so this parabola is y over 2 equals x squared. So this part of the parabola is the positive square root of y over 2. Okay, you have to change it to an equation in terms of y if you're going to integrate with respect to y. All right, so in your calculator, please put this in using Math 9 without the pi. You're going to have to use x's on your calculator, but it's set up in terms of y. Are we getting a nice number? What are we getting?
16 pi.
Oh, that's really nice. Okay. Some of us are getting 16 pi, some of us are not. Okay, the square root is over all of the x under 2.
What?
Here's what's happening.
Oh. Oh.
That work, Grace? Anyone else need help getting this answer? And if we think about the big picture, is the calculator the harder or the easier thing of all of this?
So much easier.
The easier thing. So if you're not practicing this and you can't punch something into your calculator come test time, I really don't feel sorry for you. Okay? If you have questions because you're not getting 16 pi, Now's the time to ask them. Syntax is very important, and if you can't get your syntax correctly, you're not going to get the right answer even though you set it up correctly. Okay? So if you have issues, let me know. Okay? I think I have a couple more examples. Let's go to this one. There we go. Let's go straight to it. Now this is a region we looked at yesterday, right? No, maybe not. But we have square root of x and x squared. So it's going to look like that. Do you agree?
Tiny.
Which one's this right here? This is the square root of x, and this guy is y equal x squared. Okay? Well, if we are going to, and I'm not going to draw this super accurate because I don't have the room, so I made that little break in my x-axis, and then I glued it back together. If we're going to rotate around the line x equals 10, what kind of rectangles are we going to have to use? We're going to have to use horizontal rectangles with thickness dy. Okay. Well, I just gave you equations that were in terms of x, so we need to rewrite them in terms of y. So I'm going to use some colors here. This green function right here was y equals the square root of x. Well, if we rearrange that, that becomes x equals y squared. Okay. This parabola right here, y equals x squared, this would become x equals, in this case, the positive square root of y since we're in the first quadrant. Negative square root of y is what would be on the other half of the y-axis. Okay. This intersection point right here is the coordinate 1, 1. So that makes it kind of nice. We don't have to think too hard about our limits of integration. But since we are going in terms of y, we need to look at our y intersection points. So our volume pi r squared minus r squared h. Okay. Our limits of integration would be 0 to 1. Was that?
Huh?
You made like a noise
Oh
when
yeah,
I did
no,
that.
that was like one of those.
Am I wrong?
No.
Do you disagree?
No.
Okay. All right. So if our axis of rotation is 10, x equals 10, which function is further away, the blue or the green? The green is furthest away, so that's going to create our outer radius. Now, since our axis of rotation is on the right, it needs to come first in our subtraction. So we're still working with right minus left. So we're going to have to write in 10 minus y squared for our outer radius. And then this blue equation is closest to our axis of rotation. So for that distance, we would still take right minus left, but we're going towards this blue function. So we'll say 10 minus square root of y for our outer radius. so plug that in using Math 9. I'm not sure if you're going to get a nice value out of it or not.
So when we write, do you want to make sure that like you have big parentheses around all of it times dy?
No. And I haven't been doing the best job of doing that, but yes, we will need those big parentheses.
Sometimes you just gotta start from scratch.
Okay, so I have a pet peeve. Is this changing to a fraction?
No.
Okay, please do not write 6.367 pi. Pi is an irrational number. You have an irrational number in your calculator. Go ahead and take that 6.36 blah, 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 and multiply it by pi, and then give me that decimal.
20.001.
20.001. That's what I would like to see. Okay, but if it can be turned into a fraction, I do want that because I like the nice answer of a fraction times pi. But if it can't be turned into a fraction, then at that point multiply it by pi and then give me the approximation. Okay.
Done for the day. Clock out.
Oh, that was my last example. I thought I had one more.
Shucks.
What?
Shucks.
There's no way.
Oh.
Oh, I skipped one, didn't I?
Yeah, it's about the y-axis.
Yeah, look. This was my first example, this was my second example, and that was my third example. I skipped one.
Let's go back and
Okay, so this is your job. You have to get one problem done from your homework before you leave.
Ooh.
Yeah.
This.
One day,